When discussing routing packets through a network, we can relate it from going from your dorm room all the way to your 199 class.
Now, if you were to use traceroute on your terminal, you could actually see these individual hops going to bursts. Now, right here we have our client, which is our room number, our router, which is Spalding, so houses all the clients that are in Spalding. And then it goes to the network, which is the UB North campus, which then goes to Talbert Hall's router to bursts. And now, one thing I wanted to bring up is that the center of the internet is actually faster. See, we could actually relate it. Walking from Spalding to the bus stop is a lot slower than taking a bus from Spalding to Talbert.
Now, a thing also like a routing packets is that if there's a lot of people trying to get from Spalding to their 199 class, say 100 kids, there's only a maximum number of kids the buses can take at one time, which is going to cause, slowing down. It's going to cause a buildup. So,
and that's before it enters the network, of course.
We're at Spalding, and now we're on our trip to Burt's inside Talbot. So we're about to get routed into the network. So we're going from here, and we're going to be going down to the bus station, taking a bus down, and then walking, because the bus is going to be, the middle inside of the internet. So it's going to be a lot faster than just walking from place to place. So we're on our way to Talbot Hall and then to Burt's. We're in Norton right now. We just got off the bus. Much faster than walking, much like the inside of the internet. And so we're just still walking. We should be there pretty soon.
So we just finished our journey through the network, and might I add, in record time, about 96 milliseconds actually. And we're about to, right now we're in the Talbot router, and we're about to arrive at our final destination. And here we are at Burt's.
So we arrived in Burt's a little bit later than everyone else. I guess our journey took a little bit longer than I had anticipated. But the journey to get here was pretty interesting, and much like routing packets through a network, we started off in our client, or our dorm room, then was routed through our router, or the resident hall of Spalding, going down through the internet using the properties of the inner internet, how fast it is, like using a bus, arriving here in Talbot, and then finally at our destination, much like the path that a packet will take through the internet.
So different parts of our trip were, they use different protocols. So we have IP to start. Now IP is really, it's just unreliable. I mean, it'll get to your destination, but there's no guarantee the packets won't be in order. Sometimes it actually maybe even drop packets too. And that's where our little buddy TCP comes in. Now this is another protocol. It's reliable. It offers names. It's got flow control as well as ordering. And TCP, as opposed to IP, is actually on the edge of the internet, on like your computer, whereas IP is the core internet. So going more in depth about TCP and IP, and I will get to this in a second. I know it looks quite interesting. Well, IP will actually obtain the address to start. It's sort of like a post office, like a clerk. She'll write down the address, and the postman that will deliver it. And he's sort of like TCP because he'll ensure a safe delivery. Now, a few more things. Flow control, related to our metaphor earlier with us traveling actually. Say a bus is being overloaded with packets. The bus driver will actually shut the door and go, and another bus will come, and those people were just, they were dropped for a second there. Or IP could have actually rerouted them through another bus. Now, one thing I wanted to say is when we're sent through the network, the two packets, they could take two different paths. Okay, so we have packet one here, the upper half of myself. He's saying what's up to me, and now he'll go through this path, right? And my packet two, my lower half, will go through this path. And TCP will actually ensure that I am put together in the right way.
So to continue the example about how traveling to a different destination in UB North campus is like routing packets through different routers. Say you start off in Ellicott, right? And you want to go to the student union, you want to get some lunch. So you get out of your dorm, get on a bus, come down to the student union, and let's say you have to go to the natural science complex, because you got to go to your 1:15 class. You could then go from the student union all the way to the natural science complex. And that could be one way that a packet gets routed. But let's say if you're in Ellicott and you have to go to the natural science complex, you don't want to have to take this path, then walk there. You can instead get on the bus for its second tour, come around to here, and then be really close to the natural science complex. So based on where your destination is and where you're coming from, you'll be routed through a different, set of directions. So it makes your trip faster.